Hey there folks, Elvis PEMDAS here, back talking to you about orders of operations and evaluating expressions. Now, I got a question for y'all. Why did Elvis like milkshakes so much? 'Cause they're all shook up, ooh, ooh.
First thing we're going to talk about is an algebraic expression. That's a mathematical phrase that includes one or more variables. So here we have the word phrase that we're going to start with. It says, I make $15 per hour. Now, we're going to have H represent the number of hours I work. That's going to be our variable. Our constant then is going to be that $15. So 15 is a number that doesn't change. No matter how many hours I work, I still get paid $15 for every hour that I work. Now, if I wanted to write an expression that would give me the amount of money I would earn after a certain amount of hours, H, I would write 15 times H, like I do here, or the product of 15 and H. This expression allows me to plug in whatever I want for H. So let's say I work 10 hours. I could plug in 10 for H and then do 15 times 10 and get how much money I would earn after 10 hours. That's our expression. An exponent is a quantity usually expressed as a raised symbol describing the repeated multiplication of a base. So here we have our example, 12 to the third power. 12 is going to represent our base. That is the number that is being multiplied by itself. Now this little exponent right here, this guy is going to tell you how many times you multiply the base to itself. So this is saying multiply 12 to itself 3 times. So we have 12 times 12 times 12, and that gives you 1,728. That's how exponents work. Order of operations is a collection of rules that define which procedures to perform first in order to evaluate a given mathematical expression. Now, this is what has parents and older people super confused on Facebook and Instagram. You have those problems that nobody knows how to solve. They always forget order of operations, or PEMDAS. Now, I've heard GEMDAS as well, but we're going to stick with PEMDAS. PEMDAS refers to parentheses or brackets first. Parentheses, brackets, or grouping symbols. What's inside the parentheses? That's the first thing that you do. Next, you then switch to exponents. Whatever exponents appear from left to right, you evaluate those. After you've evaluated all of the exponents from left to right, you do the multiplication and division from left to right. It doesn't matter which comes first. You start from the left side of the expression and work to the right. Lastly, addition and subtraction from left to right. Again, it doesn't matter whether it's addition or subtraction first. You start from the left and go to the right.
What did Elvis do when he couldn't find a good singing partner? He went out and bought a do-it-yourself kit. It's example time.
Example 1 says simplify. We have -5 to the second power. Now notice this -5 is in parentheses. This is a big deal because what this is saying is not just to raise the 5 to the second power and then multiply it by this negative out front. It's saying take -5 and multiply it by itself twice. So that's what we're going to do. -5 times -5. Now remember, a negative times a negative makes a positive. So -5 times -5 is going to be positive 25. 1.5 to the 6th power means we're going to take 1.5 and multiply it by itself 6 times. And when we do, we end up getting 11.390625. Part C, we have 6/7 or 6/7 to the third power, which again tells you to take 6/7 and multiply it by itself 3 times. So 6/7 times 6/7 times 6/7. If you forgot how to multiply fractions together, it's super easy. Multiplying fractions is probably the easiest thing you do with fractions. You just multiply the numerators together and multiply the denominators together. And that's it. So 6 times 6 times 6 over 7 times 7 times 7. And you end up getting 216 over 343. Part D, we have -1/2 raised to the 5th power, which means, again, we're going to take -1/2 and multiply it by itself 5 times. Again, it's important that this -1/2 is in parentheses. If it was not, what we would do is we take the 1/2, raise it to the 5th power, and then multiply it by -1. So again, all we do when we have fractions is we multiply the numerators together, put it at the top, multiply the denominators together, put that at the bottom. So 1 times 1 times 1 times 1 times 1 is going to be 1. That's in our numerator. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's going to go in our denominator. Now, is it going to be positive or negative? Well, a negative times a negative makes a positive. A positive times a negative makes it negative again. And now a negative times a negative makes it positive again. And lastly, a positive times a negative makes it negative. And you can always check. If you have a negative number that's raised to an exponent, just look at that exponent. If it's an odd number like this, it's going to stay negative. If it's an even number, it's going to turn positive.
Did you kiddos know that Elvis's daughter married Michael Jackson and Nicolas Cage? Talk about a national treasure. You try.
Okay, so again, we have 0.2 raised to the third power. That means we're going to take 0.2, multiply it by itself 3 times. So that's going to be 0.2 times 0.2 times 0.2, which gives you 0.008, or 8 thousandths. Here we have -4 raised to the 5th power. Again, it's important that the -4 is in parentheses. Otherwise, we would just go 4 to the 5th power and then multiply it by this negative out front. So here we have -4 multiplied by itself 5 times. That's going to give you -1024. Now, how did we know it was going to be negative? Remember, this is an odd exponent. So anytime you have a negative number raised to an odd exponent, it's going to stay negative. If this was an even number, it would have turned positive. Here we have 5/8 to the 1st power. Anytime you have a number raised to the 1st power, it's equal to itself, 5/8. And you're done. Easy. Lastly, -2/3 raised to the 4th power. Again, we're going to take -2/3, multiply by itself 4 times. You need to multiply all the numerators together and put that in the top. Multiply all the denominators together, put that in the bottom. Since we have a negative number raised to an even exponent, that means our answer is going to be positive. So we have a positive, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we have 16 in our numerator, 3 times 3 is 9, times 3 is 27, times 3 is 81. So our answer is going to be positive 16 over 81. And you're done. Example 2, we're going to simplify the given expression. The rules for simplifying expression, we follow PEMDAS, parentheses or grouping symbols, exponents, multiplication or division, and addition or subtraction. So let's start. Parentheses. Are there any parentheses? No. So we skip. We go to exponents. Are there any exponents? Yes, there's 4 raised to the 3rd power. What's 4 to the 3rd power? 64. Next, is there any multiplication or division? No. Is there any addition or subtraction? Yes, there's addition. So we go 5 plus 64, and we get 69. And we're done. Let's try that again. We have 2 to the 4th power minus 12 times 3. So we start over. PEMDAS. Parentheses. Are there any parentheses? Yes. But remember, this is complete what's inside the parentheses. If there's just a number inside the parentheses, there's nothing to do. We're done with that step. We move on. Exponents. Yes, there is an exponent. So we have 2 to the 4th power. 2 to the 4th power is going to be 16. So now we move on. Multiplication or division. Yes, there is multiplication. So we do 12 times 3. And 12 times 3 is going to give you 36. There's no other multiplication or division. We move to the next step, addition or subtraction. There is subtraction, so we go 16 minus 36, and we get -20. And now we have evaluated each of these expressions.
But did you know that Elvis was related to Abraham Lincoln and Jimmy Carter? Bet you didn't. Try this.
Okay, so let's start with this one. Again, start with PEMDAS. Parentheses. Is there anything to do inside the parentheses here? Yes. Let's do what's inside the parentheses. So we go 6 minus 2, and we get 4. Now we move on. After we've completed what's inside the parentheses, we go to exponents. Yes, there's an exponent. We go 4 to the 3rd power. 4 to the 3rd power is going to be 64. Now that we've completed the exponents, we move to the next step, which is multiplication or division. We have division. Yes, so we go 64 divided by 2. What is 64 divided by 2? 32. And we don't even have to go to the next step because we're done. For part B, start over. Parentheses. Yes, there's parentheses, but there's nothing to do inside those parentheses. It's just a number, 2. So we move to the next step. Exponents. Is there an exponent? Yes. 8 to the 2nd power. What's 8 to the 2nd power? That's 64. Then we go to multiplication or division. Is there any multiplication or division? Yeah, there's multiplication here and division here. But just because it's multiplication or division doesn't mean you do multiplication first. You work left to right. This is one that everybody gets wrong on the internet. You need to divide these two first because we're working from left to right. So we do multiplication and division from left to right. We do 64 divided by 4 first, and we get 16. Then we do 16 times 2, because again, we're doing multiplication or division. After we've completed all multiplication or division, we move to the next step, which is addition or subtraction. Here we have 5 plus 32, and we finish by getting 37. Now, order of operation with fractions. Anytime you have something to do in the top and something to do in the bottom, something to do in the numerator and something to simplify in the denominator, you first use the order of operations for the numerator until it's completely simplified. Then you use the order of operations for the denominator until it's completely simplified. In this particular lesson, what should happen is you should get a number in your numerator and a number in your denominator. And when you get those two numbers simplified all the way down, then you divide those two numbers. So example 3, let's start with A. We're going to first do PEMDAS for our numerator. We start with parentheses. Are there any parentheses? Yes. So inside those parentheses, we're going to simplify. -3 plus 1 is going to be -2. Then, since we simplified everything inside the parentheses, we move on. Are there any exponents? No. Any multiplication or division in the numerator? Yes, there is multiplication. So we go 3 times -2, and we get -6. Now that we've completed everything for the numerator, it's just a -6. It's just a number. We go for the denominator now. What can we do in the denominator? Any parentheses? No. Exponents? No. Multiplication or division? No. What about addition or subtraction? Yes. We have 5 plus 1 is going to give you 6. Now that we've simplified the numerator and denominator, we divide these two numbers. What's negative 6 divided by 6? Negative 1. Let's start over for part B. Again, we start with our numerator. PEMDAS for our numerator. Are there any parentheses in our numerator? No. Exponents? Yes. 3 to the third power is going to give you 27. Is there any multiplication or division? No. Addition or subtraction? Yes, there's subtraction. So we go 27 minus 3, we get 24. Now we move to our denominator. 2 times 2 is all we got. So we don't have any parentheses. Well, there are parentheses, but there's nothing to do inside those parentheses. There's no exponents. There is multiplication. So we go 2 times 2, we get 4. Now that we've completely simplified our numerator and our denominator, we divide these two numbers and we get 24 divided by 4 is 6.
Oh, ho, 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 Elvis, Elvis, I'm being Elvis, you try!
Okay, so again, PEMDAS for our numerator first. Are there any parentheses? No. Exponents? Yes, there's actually 2 sets of exponents. So we're going to do this one first, and we get 6 to the 4th power is going to be 1,296. Then we're going to do this one. 3 to the 2nd power is just going to be 9. Is there any multiplication or division? Yes, there's division now. So we go 1,296 divided by 9, and we end up getting 144. So the top, our numerator, is completely simplified. That means we can go to our denominator. Is there anything? No, it's just a 9. So we divide these two numbers, and we get 16, and we're done. Let's go over here. PEMDAS for our numerator. Any parentheses? No. Any exponents? No. Multiplication or division? Yes, there's multiplication. So we go 2 times 7, we get 14. Any addition or subtraction in our numerator? Yes. 14 plus 4 is going to give you 18. So that numerator is completely simplified now. So now we go PEMDAS for our denominator. Are there any parentheses? No. Exponents? No. Multiplication or division? Yes, there's division. 9 divided by 3 gives you 3. Now, since our numerator and our denominator are completely simplified, we divide these two numbers. What's 18 divided by 3? 6. And you're done. Now example 4 says evaluate each expression for A equal to 5, B equal to 12, and C equal to 2. So for this first one, we're going to take 5 and we're going to plug it in for A. We're going to take 12 and we're going to plug it in for B. We're going to take 2 and we're going to plug it in for C. And we plug it in, put parentheses around it. Now what you do is we do PEMDAS, just like we were doing. Start with parentheses. Is there anything to do inside the parentheses? No. So we move on. Are there any exponents? No. So we move on. Is there any multiplication or division? Yes. There's a bunch. So we're going to do that. So we start on the left and we do 2 times 12 and we get 24. Now again, it's multiplication or division from left to right. So then we're still moving from left to right. We have division now. So we do 24 divided by 2 and we get 12. Now is there any multiplication or division? Yes. So we have to do 3 times 5. Then since we've taken care of all multiplication division, we then move to addition or subtraction. We add 12 and 15. We end up getting 27 and we're done.
You ain't nothing but a hound dog. Try it all, you try.
Okay, for those of you who are a little more advanced, this is called the discriminant, but we'll get there way later. For right now, what we're going to do is we're going to take 5, we're going to plug it in for A. We're going to take 12, plug it in for B, and take 2 and plug it in for C. Now, again, we start with PEMDAS. Are there any parentheses? Yes, but there's nothing to do inside those parentheses, right? It's just numbers. So we move on. Are there any exponents? Yes, we have 12 to the 2nd power. That's going to be 144. Now, there's no more exponents, so we move to multiplication or division from left to right. We start with this. What's 4 times 5? That's going to be 20. Then we move to 20 times 2, and we end up getting 40. Now that we've taken care of all multiplication division, we move to addition or subtraction, and we have 144 minus 40, which gives you 104, and you're done. So our word problem says you earn $15 for each hour you work at the Sugar Shack restaurant. Your boss also gives you a bonus of $50 for doing a great job. Write an expression for your total earnings after receiving your bonus and working 10 hours, 20 hours, and 30 hours. Then determine how much money you earned for the given number of hours worked. So here's what we're going to do. We're going to create a table with our hours worked, our expression, and then the total amount of money earned. So let's start with 10 hours worked. Our expression, how do we write that? Well, let's see. We have $15 for each hour you work. So that's going to be 15 times however many hours you worked. In this case, that would be 10. So 15 times 10 gives you how much money you earned after 10 hours. But also, you're given a $50 bonus. So we're going to add in $50. So it looks like this. 15 times 10 plus 50. When we simplify this, we must do the multiplication first and then the addition. So we do 15 times 10, which gives you $150. Then add that to $50 $50 and you get $200. For 20 hours, you're going to do the same thing. It's going to be 15 times 20 this time, because that's how many hours you worked, plus that $50 tip. So we go 15 times 20, 300, plus 50, which gives you $350. Lastly, 30 hours, 15 times 30 this time, plus 50. So what's 15 times 30? That's going to be $450 plus 50 gives you $500, and that's how much money you would earn.